There are two final topics in 8.3, and the first one is when you add up a whole bunch of numbers that you've gotten from a geometric sequence, and then you get to the last number, and when you add them all up, they're going to equal what they call a sum. So the sum of a finite geometric sequence means you start out with one number and you end at a final number and add them all up. The way we're going to designate those numbers is the very first number is going to be called a sub 1, and the next one will be a sub 1 again, multiplied by the common ratio. Then the next number is a sub 1 again, multiplied by the common ratio, multiplied by the common ratio, or the common ratio squared. And you continue this pattern until you get to the very last number. Now, the way we'll do it is we're going to write out that we want S sub n. I want you to jump down to example 6 and you'll see what I mean. This example right here is that they want you to add all the numbers from this rule, starting with 1 going in for n, then 2 goes in, 3, 5, 7, 9, 10, 11, all the way to 12. And when you add all those numbers with this formula, you're going to get the following numbers. I'll start with 1, I'll plug it into n, and I get 4, the initial a sub 1 value, times the common ratio, which is 3/10. So really we're taking 4 and we're multiplying it by 3/10 to the first, which means we're going to get basically a smaller version of 4, 3/10 of 4. Then we're going to take 4, add to it 3/10, and we're going to take that 2 between 1 and 12. We've gone from 1 now to 2, and we put the 2 up there. And then 4, 3/10, 3, ... all the way out to 4, 3/10, 12. Now I could do this on my calculator, but it's really slow and very big hassle. So what we do is we show the sequence in the problem like this. They'll usually start with I or N or K or C, some variable here, equal to 1. That means that's the first number you're going to put in right in the I spot. And then we're going to go all the way out to this number, whatever it is. And they'll show you the number as they did here. They showed it's 12. Then they'll give you the initial value, and then they'll give you the common ratio, and then they'll tell you what goes up here. Now, normally, it's going to be I minus 1, or it might just be I, or if this letter is an N, it'll be N minus 1, or just N. So we did that process right here where they used just n, and when we did, we had a whole slew of numbers out to the 12th number, which is tedious to add up. But there's a faster way, and the faster way is to use this formula right here. Now this formula was introduced in class, but in case you didn't get it, a sub 1 is going to be your first term, which is this thing right here. It's the very first number you put in, 1 goes into your formula. Then we're going to multiply it by a fraction. The numerator of the fraction is 1 minus the common ratio to the nth term. What's the nth term? Well, if you look, the nth term here is going to be whatever number you're going to use, which is going to be all the way out to 12. And then you have 1 minus the common ratio down below. So we did it the old-fashioned way, which was tedious. Now let's use the faster formula. Before you do, be sure you write down the big information, which is what's the first term, what's the common ratio, and where do you go to? Remember, on this problem, we go all the way up here to 12. So we're going to write all those elements out, and that's our given information. If you don't write down the given, you're probably not going to get the problem right because you'll forget something. So we write out the original problem they gave us. We notice this is a sub 1. We notice that this is the ratio, and this is n. Notice how they have n here. If they had an I here, there would be an I up here. If they had a K, there would be a K up there. So these two variable letters always match. They're called the index. So now we're going to use the shorter form, which is this formula here. You should write it out generically, and then plug in what you know a sub 1 is. Now you get a sub 1 by using this formula, using 1 for that right there. And when you do, you're going to get 4 times 3/10 to the first. So we write that out as a sub 1. Then we write out the formula 1 minus, put the common ratio, r, and then you put n. Now the n is how many numbers you go to. In other words, we started at 1, we went out to an ending number. What's the ending number? And that's going to be 12. So if you'll just look at the top of your summation symbol, that number goes right there. Then you look at the bottom, 1 minus r, and that's just 1 minus the common ratio, which is 0.3. Get your calculator out. When you do it, that's the answer you come up to. Be sure to use a calculator to do it. Okay? Now, the next problem is very much like the previous problem, but instead of starting at 1 in the next problem, they start at 0. And when they do start at 0, then even though we're going to 12, look at how the end number is going to vary. Because when we do this, if you'll read right here what it says, you start at 0, you have to adjust the formula for the nth partial sum. In other words, you have to take into account, we usually start with 1, so we have to figure out a number in addition to the original summation we had up here. So that number is the 0 term. So all we do is plug in 4 times the common ratio to the first term, which is 0. Then we add our answer from above. And if we do that, we have 4, the problem from above, which is 1.71, we get our answer. So that's how that last part works. The next part has to do with geometric series. Now, a geometric series is a little bit different than a geometric sum. The key to it is right in this box and the information right here. Basically, what we're going to do is we're going to take this same thing we had before, but we're going to go all the way to infinity. Notice in the previous box, we went to a specific number and we stopped. Here, we're going to do the exact same thing, but we're not going to stop. We're going to go on to 500, 700, million, billion, Google. In other words, we never end. We can't add those up to infinity, so we have a formula. Before we start with the formula, it's important that you realize that we're going to infinity, meaning we must check our common ratio. Here's the deal. If your common ratio is less than 1, if it's a fraction, you can use the formula that we have down here. But if your common ratio is not less than 1, the problem cannot be done. All right? So we're going to go right into the formula. First of all, the common ratio has to be less than 1. If it is, then we're going to have a whole bunch of terms, numbers, added up together, but they're going to go to infinity. We can't do that by just adding them, so instead we use this formula right here. This is not the same formula we had before, which was this one. It's changed. It's much simpler. We put our first term on top. On the denominator, we put 1 minus the common ratio. That's it. So what are we going to do when we have r that is bigger than 1? Your answer is we don't have a sum. Does not exist. So make sure your ratio is less than 1. It's a fraction. Example 7 is excellent. Let's start out with part A. We go from n equals 0, meaning we're going to put 0 in for n, and we go to infinity. No way we can do that by adding up by ourselves because it would go on forever. And that's what they're trying to show when they do this right here. You see that they put in 0. When we put 0.6 to the 0, we get 1. And so we end up with the first term being 4. Then we put in a 1 right there. Then we put in a 2. Then we put in a 3. Well, this gets old real quickly. We go out to the nth power, and n basically continues forever and ever until it reaches infinity, which it never does. Because we can't do it that way, we're going to use the formula. So we go back up to our formula. We put a sub 1, the first term, on top. Look at the a sub 1 term. Notice this is our a sub 1. And when you're figuring out a sub 1, that means you're going to start at 0, plug it in there. 0.6 to the 0 is 1. 4 times 1 is 4. So that's a sub 1. Then 1 minus the common ratio. Now when you do the math on that one, using this formula, because r is less than 1, hello nurse, you end up with an answer of 10. Now part B says, well, what if we give you the actual numbers and say they go to infinity, and we don't tell you what the rule is? In that case, you're going to have to figure out what the ratio is. So we look at 3 and we say, well, what did we do to 3 to get to 0.3? Well, if you think about that, to get from 3 to 0.3, I basically had to multiply by 1/10 the 3. So my common ratio is 1/10. Because whatever I do to get from one number to the next, if it's the same thing, then that's your common ratio. In this case, it's 1/10. Is 1/10 less than 1 absolute value? Yes, it is. Therefore, I can use my formula that's right up here. So I'm going to plug in my formula. There's my first term because I got it right out of my list right here. And I'm going to show the first term on top, which is a sub 1. And then I'm going to say 1 minus the common ratio, which is 1/10. You can write it as a decimal or you can write it as a fraction. Then you do the math on this, but when you put this into your calculator, you can do the denominator pretty easily. That's just 0.9. So it's really 3 over 0.9. And when you do that, it ends up 10/3 or 3.333, and that's your answer. Now, if you want some practice on these, you can go to exercise 75, which I believe was one of the homework problems. And for the previous one, you can go to exercise 55 for example 6, or you can look at the example I have right here, and this is a real good one. Take a moment to look at it. You can see how they did it on a calculator, review it, and that would help you understand how to do the problems. Good luck with these, and good luck on your upcoming test. If you have questions, be sure to come and see me.